started streaming the session, and we are also going to start recording it just for the information of everyone. Okay. Um, okay, so I hope my whiteboard is visible. So let's begin. This session will be focusing on the topic of optimization. Right? And yeah, this is a shift from our regular content of the course because till now, whatever models we were doing were primarily about modeling systems, right? Optimization goes one step further. More than modeling a system, after modeling, it's also going to prescribe something for you. So you are going to do model and you are going to do some prescription, right? So both are going to be done by optimization. And our focus here is basically to introduce the concept of optimization. What are the primary three pieces, three important, let's say, pieces of any optimization formalization, and what kind of insights you can get from them, right? So that is all is going to be the focus here. Very very basic concept, right? Having said that, any optimization requires three. If you have three things, it's known as an optimization problem. All right, and we are going to be focusing on something known as the linear program. So it's known as an LP, right? So any linear program consists of three things. Okay, the first one, what is it? Anyone? Any idea? What is the first piece of linear program? The second and the third. Three components. The first one is known as the objective function. The second is the decision variables. And the final one are the constraints, right? So any optimization problem will have these three things: an objective, a target that you want to do, what activities you should do to get the best result for the target, and for doing these activities, what are your limitations, what are your constraints, what are your, let's say, upper and lower bounds on the variables that you can control. That is specified by the constraint piece. So once you create these three, you have basically created a program which can be solved as an optimization. And if all of these, basically number one and number three, if both of these are linear in nature, if the objective function is linear and the constraints are linear, then it is known as a linear program. And linear means it should all the terms in it should be of power 1, right? So linear implies power 1. Okay. Now, to drive home this concept of formulation, what I will do is I will uh, paste a sample problem for you in the chat. So that is the problem that we will be solving or formulating today. Okay. So we'll formulate this linear programming problem, and I want you guys to tell me what are the constraints in it, what are the variables of interest, what is going to be our objective, so that we can take it step by step, right? So what is this problem all about that I've posted in the chat? Anyone? What is my objective?
So 6 unit of R1 plus 4 unit of R2.
No, that is not my objective. What is my objective? The last line. What does it say? Can you read the last line of the paragraph?
I mean 24 R1 plus 6 R2. That is 24 units of R1 available and 6 units of R2 available. Then how many cars and
Okay.
dogs should be?
Then how
So
many?
cars and dolls should be produced to maximize the profit. So we have
So your objective is what?
to maximize the profit.
The profit. So the objective is maximize profit. And what is profit? What is profit? How do I calculate profit for this problem? The third line. Every car sold gives a profit of ₹5 and every doll a profit of ₹4. So what is my profit? It is 5 into number of cars that I sell plus 4 into number of dolls that I sell. Right? So that is going to be my profit. Everyone with me so far? My objective is to maximize profit, which is nothing but maximize. I get a profit of ₹5 for every car that I sell. So ₹5 into the number of cars that I sell and ₹4 into number of dolls that I sell. So to maximize this, 5 and 4 are fixed. What should I find out? I must find out the number of cars that I produce and the number of dolls that I produce. So from the objective function, you determine what are your decision variables. So your decision variables here are two. Let's call them x1 and x2 because we are always interested in finding our x's, right? So x1 is number of cars that is sold and number of dolls that, okay, or sold, right? I sell 10 cars and let's say $4. What is my profit? 5 into 10 plus 4 into 4, which is going to be 50 plus 16 or 76. 50 plus 16, 66. So that is going to be the profit that I get because I am selling 10 and 4. The question is, you must find these 10 and 4. What is it really 10 or is it really 4 or is it a different combination? Making sense? So the question is, I want to have an objective of maximizing my profit. My profit is basically for every car I sell, I get some value. Every doll that I sell, I get some profit. So how many do I sell? Totally, how many do I get? So that is my objective. And to find my objective, I must find how many cars I must sell and how many dolls I must sell. Okay. So if I just ask you to solve this problem without any constraints, what will happen? There are no constraints here on x1 and x2. So what would be my value for my objective function?
Infinity.
Why infinity?
It will make this max function
If I'm
highest.
having a max function, I will try to push my number of cards and push my number of cards as high as possible. So what will happen? It will be rupees 5 into infinity for number of cards. I keep on selling cards plus rupees 4 into infinity because I'll keep on making and selling dolls. So my entire objective function but be infinity. But that is not the case. Why? Because there are limits on the number of cards that I can produce, number of dolls that I can produce. Where do they come from? They come from the raw materials that are available. So once you have defined the objective function and condition variables, you then start looking at the constraints. And these constraints are nothing but the limits on the decision variables, DVs. These are your decision variables. So a constraint is basically a limit, which means it is going to have an RHS, it is going to have a LHS. And this RHS and LHS are going to be related either as a less than or equal to or as a greater than or equal to RHS, LHS. I think I've written it wrong. One second. This is my right, this is my left. So I have a left hand side, I have a right hand side, and the left hand side and right hand side is either less than or equal to, greater than or equal to, or equal to, right? So I will be writing equations which will be of this form. One of these. Yeah, the equations will come such that a left hand side will come which is less than or equal to a right hand side value. A left hand side thing will be given which is going to be greater than or equal to a right hand side value, and the left hand side equation is going to be equal to the right hand side value. If I write something of this sort, then it is known as a constraint. Okay. For this problem, what are the constraints? Anyone? What are the constraints? Can you read and tell me? Anyone?
They are constrained on raw material R1 and R2.
So constraints are always on the raw materials. So constraint on R1 and constraint on R2. So what is the constraint on R1? What is the constraint on R2?
So R1 has to be less than 24 units,
Okay, less than
and
24?
less. Let me check. There are 24 units. Means no, I guess it is equal.
less than or equal to. I have 24 units. I can consume or 24 or I can also consume 20. Not a problem. It should always be less than or equal to. Right?
Yes.
Okay. So then what is the constraint? Then the right hand side is going to be less than or equal to. Right? 24 is going to be on the right hand side. The inequality we are going to use is less than or equal to. What is the left hand side?
R1.
Left hand side is R1. Or R1 you are writing.
Yes.
R1 now. Okay, let me write R1 since you are telling R1. These should be limits on your decision variables. So, what are the decision variables? The number of cars you are going to produce, number of dolls I am going to produce. So, if I produce one car, how much units of R1 am I going to consume? For every car that I produce, how much R1 am I going to consume?
6 units.
6 units of R1. So, if I produce one car, it is 6 units. If I produce X1 car, I am going to sell X1 cars, which means I must produce X1 cars. I will consume 6 into X1. For every doll, how many do I need?
24 units.
For every doll, you need 4 units. 4 into X2. So if I produce one doll, I will consume 4. If I produce X2 dolls, I will consume 4 into X2. So if I, based on X1 and X2 that I produce, 6X1 plus 4X2 must be less than or equal to 24, which is the total available. I have 24 units of R1. If I decide to make 5 cars, I would require 5 into 6, which is 30 units. I don't have 30 units, so I cannot produce 5 cars. I can only produce 4 cars. 4 6 are 24, which means I cannot produce any dolls. Making sense?
Yes, sir. Sir, for doll, you requires only 1 unit of R1.
I require only 1 unit of R1. Each doll requires 1 unit of R1. Yeah. Okay. So then this is 1 unit. Okay. Correct. Fine. So for every doll, I require 1 unit of R1, and for every car, I need 6 units of R1. So 6x1 plus 1x2 must be less than or equal to 24. So now you have a left-hand side where you have the decision variable, and the right-hand side, which is the limiting number, which is a RHS value, which is 24. This is same as writing this equation as 6x1 plus x2 minus 24 less than or equal to 0. Right? This same equation, I can also write it like this. There is no difference. Bring this 24 this side and write it. The same equation, I can also write it as 24, 0 must be less than or equal to 24 minus x2 minus 6x1. This is also the same. Okay? Whether you write it as 6x1 plus x2 less than or equal to 24, or 6x1 plus x2 minus 24 less than or equal to 0, or 0 less than or equal to 24 minus x2 minus 6x1, all of them are the same thing. Remember that. Okay? I'm telling this for a very specific reason, which I'll come to later on. Okay. So this is the constraint on R1. What is the constraint for R2? What is the constraint on X1 and X2 because of R2? What is my RHS?
4x1.
Okay, you're telling me the entire thing. Okay.
Yeah, I mean the 4 units of R2, that is 4x1.
Plus
2x2.
2x2
less than or equal to 6.
less than or equal to 6. Because I have a total of 6 units of R2. For every car that I produce, I'll consume 4 units. For every doll that I'll produce, I'll consume 2 units. So based on the number of cars and dolls that are recommended, the total number should always be less than or equal to 6. Right? I can go up to 6 or I can go for a number that is smaller. Everyone with me so far? Any doubts? No doubts? Super. There is also a final constraint on your x1 and x2. Can I decide to produce, let's say, 5 cars and minus 2 dolls? Is that possible? Can I have a solution which says x1 is equal to 5, x2 is equal to minus 2? Does it make sense?
No, sir.
No. Why? Because I cannot buy a sell minus 2 dolls. Basically, I cannot ask someone to return 2 dolls back to me. Right? So that usually does not happen. So after your constraints, which are logical from your problem, you had a final one which is known as the non-negativity constraint, where you say x1 is a number which is greater than or equal to 0 and x2 is a number which is greater than or equal to 0. This is known as the non-negativity or non-neg, right? So the non-negativity constraint specifies that your decision variables must be non-negative. They must be a number that is greater than or equal to 0. So now your entire problem basically has constraint number 1, constraint number 2. Usually these two is put together and said as constraint number 3, non-negativity on the variables. So this problem has 3 constraints, 2 decision variables, and the objective of maximizing profit, right? So for the benefit of something, let me write all of this again over here. So I want to maximize profit, which is nothing but maximize 5x1 plus 4x2 such that 6x1 plus x2 is less than or equal to 24. X1 plus 4x1 plus 2x2, 4x1 plus 2x2 is less than or equal to 6, and x1 comma x2 greater than or equal to 0, right? So let me just check whether you have said it right. Each car requires 6 units of R1 and 4 units of R2, 6 and 4. Each car requires 1 unit of R1, 2 units of R2, so 1 and 2. Every car sold at rupees 5 and this at 4, 5 and 4. If there are 24 R1, 6 R2, and 6 R2. Okay. So this is now the LP formulation. LP formulation for the verbal business problem that is given to you. If you solve this, you will optimally know the best combination for x1 and x2 such that you can maximize your profit. Okay. Everyone with me so far?
Yes, sir. Sir, one thing. Sir, this x1, x2 has to be integer, na? That can also be one constraint because answer can
yes.
give some point value, but
Yes, yes.
cars and those.
Yes, you can say that x1, x2 must be an integer, then it becomes an integer linear program. Since we are not very much focused on that, I'm just calling it as linear program for the time being. But yes, in this specific problem, you will specify this as x1 and x2 must be greater than or equal to 0 and must be integers. Okay?
Okay, sir.
Right. So this is the LP formulation of the problem. This type of formulation is known as the primal. Okay, I'll come to the name later, but it's known as a primal. And all primals, or in general, this is a primal, a standard form of a primal, and the primal standard form is of the function, is of the type, the objective function must be a maximization. All constraints must be less than or equal to type. So if you get the primal where the objective function is to maximize and all the constraints must be of less than or equal to time, less than or equal to type, then such a formulation is known as the standard form of the primal. When I say all constraints, I do not include the non-negativity. Basically, your decision variables are always going to be greater than or equal to 0. So excluding this guy, excluding this requirement, you check all the other constraints. If they are of the less than or equal to type and the objective is of the maximization type, then it is known as the standard form of the primal. So this question that you see here, that you have formulated, is it of the standard type? Is it a standard primal? Yes, it is. So this is a standard primal, right? Because it is maximization and all my constraints are of the less than or equal to type, and I have a non-negativity constraint as well. So it meets all my requirement. Okay. Now a question. Let's say in the same problem, instead of maximization objective, if you had the objective as minimization, just for example, let's say these were costs and you have to minimize 5x1 plus 4x2. You had a minimization objective. How will you convert it to a standard form of the primal? How can I convert a minimization function to a maximization function?
Multiply with minus sign.
Why that works? So minus 5x1 minus 4x2. Why will that work? Logically,
Both will be equivalent. Like if you try to minimize this and if you try to maximize negative of that, means you are trying to minimize that.
in a scale, 4 is here, 5 is here. In a maximization scale, minus 4 is here, minus 5 is here. So if I want to minimize, I want to move towards this guy. I want to move from 5 towards 4. If I want to maximize, I want to move towards minus 4 from this person because this guy is higher than minus 5. So that is why mathematically the minus sign works. Just multiplying an equation with a minus and will automatically change the function from a minimum to maximum or maximum to minimum. So if you are asked to bring something to a standard form, if the objective is a minimization objective, you just multiply it with a minus 1 to get it to the maximization objective. Super. Let's say this constraint, 6x1 plus x2 less than or equal to 24 is of the form 6x1 plus x2 must be greater than or equal to 24. If you have this, what will you do? This, say you are given this guy. If you want to convert it to a standard form, I want to convert this to standard form, which means the less than or equal, the greater than or equal to must be of the less than or equal to type. What will I do?
And 6x1 and x2 to the other side of 24.
The same thing again. Minus x1 minus x2 is going to be less than or equal to 24. Less than or equal to minus 24. Do the same thing again. Or if you are not getting this, look at this guy. do this operation, moving it to the other side, right? Moving it to the other side. 0 must be greater than or equal to 24 minus x2 minus, okay, this will be difficult to understand. Let's not do it. No need. Let's not get confused. This will work. Same logic, right? Minus 6x1 minus x2 less than or equal to minus 24. Why? Again, look at the scale. You have 24. You want to move away from 24 by adding 6x1 plus x2, which is same as saying you have minus 24. You want to move away from it by adding minus 6x1 minus x2, right? So the same logic of this scale also works here. Instead of the greater than or equal to, it now becomes a less than or equal to by putting minus, by multiplying the entire equation with minus. Say you had this. Say it was 6x1 plus x2 equal to 24. How will you convert this to a standard form?
So in this case, we will write two equations.
Why? What are the two equations?
That is 6x1 plus x2 less than or equal to 24.
Okay.
And then minus of that entire thing.
What is the second equation? It's going to be 6x1 plus
Plus
x2
greater
greater than or equal to 24.
Yeah.
What does that mean? I must be less than or equal to 24 and greater than or equal to 24. The only answer that solves is equal to 24. So you first, step 1 is split the split the equality constraint to two non-equality constraints of the less than or equal to type, greater than or equal to type. This is already in the standard form. This time you must convert to standard form. How do you use it? You use the previous logic of multiplying with minus. So you go in for minus 6x1 minus x2 must be less than or equal to minus 24. That is all. So always remember, when you are converting to a standard form, if the equation is of the greater than or equal to type, you multiply it with minus 1 and add and keep the equation. If it is of the equation type, you will basically be replacing that one equation with two equations and then convert the second equation, which is of the greater than or equal to type, to the standard form by multiplying with minus 1. Okay. So whenever there is an equality constraint, the original problem, let's say, had two equations, two constraints, one of the less than or equal to type, the other of the equal to type. The standard form of the final will have three constraints, all three of the less than or equal to type. Okay?
Sir, according to the standard form, you mentioned that the constraint must be less than or equal to.
Correct.
So, is there any possibility that there might be an equation which is less than and the equal to is not there?
Very, very rare. Very, very rare. But usually what you will do is you will make it as less than or equal to and solve the problem. That is all.
Okay.
Very, very rare. You will add something known as a slack variable and then make that as a less than or equal to and solve the problem.
Okay.
Right?
Okay.
Okay. So this is known as the primal and its standard form. Everyone clear up to this point? Any doubts? Any doubts? Okay. After this, you have something as the dual. And for dual, always have this practice. The dual you will get it from the standard form. Right? Always convert the primal to its standard form and then get the dual from the standard form of the primal. Okay? Because when you do this, it's a very simple conversion. Where the dual, if the objective function was a maximization, in the dual, the objective function will be a minimization. If your constraints are of the less than or equal to type, in the dual, they will be of the greater than or equal to type. And what will happen is the number of dv's in the standard form of the primal will be equal to, any guesses what it will be equal to?
Number of constraints.
It will be equal to the number of constraints in the standard form of the dual. So what will be the number of decision variables in the standard form of the dual? So the number of decision variables in the standard form of the primal is equal to the number of constraints in the standard form of the dual. What is the number of decision variables in the standard form of the dual?
Number of constraints in the standard form of the primal.
That is the number of constraints in the standard form of the primal will be equal to the number of decision variables in the standard form of the dual. Super. Now using this, for the same problem that we just did, where we had maximize 5x1 plus 4x2 such that 6x1 plus x2 is less than or equal to 24. X1 plus, no, it is 4x1, right? Or 2x1? 4x1, okay. 4x1 plus 2x2 less than or equal to 6. X1 comma x2 greater than or equal to 0. This is the standard form of the primal for our problem that is given. To convert this to the dual, number of dual decision variables is equal to what? Number of constraints in the primal. So we have constraint number 1, constraint number 2. So we will have 2 decision variables. Let's call them y1 and y2. That is first out of the way. What is the objective function? Objective function is to minimize. Minimize what? A product between the two decision variables, some product between the two decision variables. What is going to sit here?
24 and 6.
Why? Why? The hack is basically for every constraint there is a decision variable. So whatever is the RHS, pull that and keep it over here. That is fine. But why? Why? Any idea why you give 24 into y1 plus 6 into y2? It is because the dual decision variables are basically called the dual price, which is also known as the unit worth of a resource, right? So I have two resources, R1 and R2. These two resources, I have 24 units available for R1, 6 units available for R2. If I really need a resource, how much am I willing to pay to get 1 unit of that? That is basically your dual price, Y1. So if I have 24 units of R1, if I'm willing to pay 5 rupees per unit for R1, 24 is 5 is the total worth of that resource for me. 5 is the unit worth, 24 into 5 is the total worth of that resource to me. So what will I try to do? I will try to minimize or identify the optimal worth of a resource for me. So if a resource I already have an excess, I will not buy that. Its worth for me is 0. Let's say I already know completely about optimization. You will not come for today's class. The session is going to be worthless for you. But let's say you do not know about optimization, you will come for today's class, which means the session is worth to you. How much is it worth to you? Each person differently, right? So that is what your decision variables are. And hence, you multiply that with the total available resource, which is 24 and 6. Over and above 24 and 6, do you require Y1? Over and above 24, do you require Y1? If yes, how much cost are you willing to pay for it? Over and above the 6 units of R2, are you willing to pay for R2? If yes, how much it is worth? So that is what your Y1 and Y2 will tell you. Super. So that is minimization, your objective. What are the constraints? Constraints are always going to be for your decision variable. So it's always going to be for your Y1 and Y2. And they are always going to be of the type greater than or equal to. Because the hack is in the standard form of the primal, the objective function is minimize and all constraints are of greater than or equal to type. Are of the greater than or equal to type. So these are all going to be greater than or equal to. So how many constraints will I have? I will have the number of decision variables. Number of constraints in the number of constraints in the standard form of the dual will be the number of decision variables in the primal. So I have two decision variables, x1 and x2. So I will have two constraints. What are they? What are the equations? Can someone tell me? What is the first equation?
So 6x1, y1 plus y2 greater than equals to 5.
Why? Don't tell me the hack. Okay, what is the hack that you used? What is the shortcut that you used? Where does this 6 come from? Where does the 1 come from? Where does the 5 come from? It's not 1y2, it is 4y2. Okay, where does the 6, where does the 4, and where does the 5 come from? So, here, always remember the RHS are the objective function coefficients. So it will always be 5 and 4. That will be your RHS. Your LHS are the constraint coefficients corresponding to a specific x. What do I mean? So if I put 5 here, which is corresponding to x1, the decision variables y1, y2, y3, whatever, will be taking the corresponding coefficients of x1 from each of the other equations. So 6y1 plus 4y2 must be greater than or equal to 5. Then 1x1, 2x2. So 1y1 plus 2y2 must be greater than or equal to 4. That is going to be the 4 for x2. So take the corresponding coefficients and multiply them with the decision variables of your dual. If you do this and then say y1 and y2, y1 comma y2 greater than or equal to 0, you have formulated you have converted the primal to a dual form. All of you with me so far? Any questions? No questions? How many of you are still awake?
No questions, sir.
Okay. 2 people are awake. Okay, fine. Right. Now, okay, if you are interested, I'll tell you why this equation comes like this. If you want to know, or else if you guys are comfortable, I'll not waste the time and I'll go forward with the naming of why the primal, why the dual. You guys want to know what is the funda of why 6, 4, 5 comes?
Yes, sir.
Okay. What are we worried about? We are worried about the worth of resource, right? So y1 and y2 is what is the worth? What is the willingness I'm willing to pay for this resource to get it. Now, if I am willing to pay y1 for resource for resource 1, what happens? I spend 5 rupees. I get a profit of 5 rupees if I spend that resource if I spend that money to get that resource to make the product. I make a product and I sell it, I will get 5 rupees. But for making that product, I need to spend 6 times y1 for getting it. So is it really worth for me? Is the question. That is why 6 into y1 plus 4 into y2. To make 1 unit of x1, I need 6 units of 6 units of r1, 4 units of r2. y1 is the unit worth of r1. y2 is the unit worth of r2. So to get a profit of, let's say, 5 rupees, how much am I willing to spend for R1? 6 times that is its worth for me. How much I'm willing to spend for R2? 4 times that is the worth for me, and that should be greater than what I am actually getting out of the product of 5. Right? Which is 5. I hope that makes sense. I make a profit of 5. My worth of resource, my total worth of resource must be greater than or equal to 5 for me to invest and get that resource for me. Yes, no?
Yes, sir.
Obviously, someone is going to say yes only. Okay, fine. Okay. So that is the conversion of a primal to dual, dual to primal, and the hacks around it. The more fundamental question is, why is this guy called the primal and this guy called the dual? Okay. So to answer this question, you must look at the decision variables. What is x1? What is x2? What is x1? What is x2? What are the definitions?
X1 is refers to car and X2 refers to number of dolls.
Number of cars that I sell, number of dolls that I sell. What is our original problem focusing on? The original problem focuses on is basically asking you how many cars and dolls should be produced to maximize the profit, right? So any LP formulation which directly gives you a response for the question asked, that becomes the primal. That primal, if you develop a dual which is going to calculate the worth of the resources used, that is known as the dual. So the primal is always going to have a decision variable which is directly going to answer your question. So if the same thing, if the same problem that I've given to you, instead of the toy manufacturer is talking about the resource, let's say the raw material supplier. Let's say a raw material supplier is supplying R1 and R2. And he is asking the question, what should be the price of R1, what should be the price of R2? Then the dual formulation that you just created, that becomes the primal, and the dual of the dual, which is the current primal, becomes the dual. Making sense? Yes, no? Let me write it on the board then. Any formulation whose any formulation in which the decision variables directly address the question asked is the primal. So in our problem, the question asked was how many dolls I should produce, how many cars that I should produce. So the formulation that we did is known as the primal. 5x1 plus 4x2, maximize that. That directly addresses my problem and tells me how many cars, how many dolls I should produce to maximize my profit. So this is the primal. If the same question was for what price should I charge for my raw material, R1 and R2, then I'm basically talking about what is the unit worth of the raw material or unit worth of the resource. So that becomes my question. Then the dual formulation which you just did is actually the primal for your problem. Okay? Making sense?
Yes, sir.
Okay. So this is basically a very, let's say, a super fast crash course on the optimization topic. Please make sure that you solve the previous question papers that are answering that are related to these questions. It will give you a lot of insights as to how to formulate a problem, look at the constraints, so on and so forth. We usually ask this in our questions, in our quizzes and in terms. Okay, one more thing. We should have actually done logistic regression by now for the quiz, but however, for quiz 2. However, since we have, I don't know where we have missed a week, since we have missed a week somewhere, or we are lagging behind a week somewhere, we will be doing logistic regression next Tuesday. So make sure that you prepare logistic on your own. Again, the TAs would have already covered solving problems in logistic regression. If in case if you have any doubts, you are welcome to ask, or else we'll cover that topic next Tuesday. And from next Tuesday, Swaminathan will be coming for the session. Okay. Any other questions?
For quiz 2, any tips, sir?
To any tips? Yeah, I do have one. Please prepare well. That is all. Look, if you solve your previous year question papers like last time, it should be fairly good. But you should not expect. Um, you should not be limiting yourself to only what the videos say. You should be doing a bit more, let's say, exploration on topics at an IITM level. You should be exploring a bit more depth into the topics that are there, so that you are prepared for the quiz. The quiz will always be 1 or 2 steps higher than the content that is being delivered, because you should do some self-learning as well. Okay, so that is the tip or the hint or a let's say fearful statement for you guys, however you want to take it. Or how much weightage can we expect from week 8? I can't tell you all of this now. I can't tell you how much weightage and all. We are not in that level anymore. You should prepare for all weeks. Okay, so that's all from me on content. Any other questions? I hope it was useful. Please feel free to ask us any doubts that you have, either during the TA sessions or during the live, or of course you also have the discourse. We'll be happy to answer. Yeah, and your TA session has been moved to tomorrow evening 5 to 7 because of the quiz on Sunday. So we'll not, the session on Saturday, which is the usual TA session, has been moved to tomorrow, so that it benefits both you and the TAs who also have quiz on the 16th. Okay. Right, so we have 9 people on the call. If there's nothing else, we can wrap up today.
Thank you, sir.
Yeah, thank you.